In this class, now I am going to explain you Euler equation. So before going to learn about Euler equation, let us see the expansion of e power x. You know, e power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x3 by 3 factorial plus x power 4 by 4 factorial plus x power 5 by 5 factorial and so on. Like infinitely many terms will come. So where x belongs to any real number. So if you keep on extending like that, so somewhere you may get nth term like this, x power n by n factorial and so on. See, in the next step, I am going to replace this x by ix. If you replace x by ix, then it is going to be 1 plus ix by 1 factorial, which becomes 1. Now go here. If you write here ix whole square by 2 factorial plus ix whole cube by 3 factorial plus ix whole power 4 by 4 factorial plus ix whole power 5 by 5 factorial and so on. So in the next step, see students, this one I am writing as it is, even this one also write as it is by 1. So here, distribute the square to I as well as x. So then it will become I square into x square. I square value, I means there you know, that is iota. I square is equal to minus 1. So if you write here minus 1, then it will becomes minus x square by 2 factorial. Now here I cube is equal to, you know, you have to write I cube like this. I cube is equal to I square into I. I square value minus 1. Minus 1 into I, minus I. So if you write here minus I, then it will become minus I x cube by 3 factorial. Now go to the fifth term. So what is given in the fifth term? I power 4 x power 4. So here I power 4 should be written as I square whole square. I square value minus 1 whole square, which becomes 1. So here 1 into x power 4 by 4 factorial. Now what about this I power 5? So I power 5, how you have to write? I power 4 into I. I power 4 value 1. 1 into I. So here I into x power 5 by 5 factorial plus and so on. So observe me in the next step what I am going to do. E power ix. See, here I kept one bracket in which I am going to write real terms. Means in this which are not having I. So in which terms there is no I? In the first one. In the third term, minus x square by 2 factorial. Next, here we have, that is x power 4 by 4 factorial and so on. Plus, now take I common from remaining imaginary terms. Here we are having 1i and here we have 1i and here take I common. If you take I common, here x will come and here minus x cube by 3 factorial and here it is going to be x power 5 by 5 factorial and so on. I hope you have understood how I have written this step from this. See, in the next step, See, observe, this is real part and this is imaginary part. So actually it is one complex number having real part and imaginary part. So in the real part, what expression have we got? 1 minus x square by 2 factorial plus x power 4 by 4 factorial plus and so on. It is getting like this. In the next term, here plus minus plus, next year we will get minus x power 6 by 6 factorial. This will continue. Actually this is the expansion of cos x. What it is? Expansion of cos x. So that e power ix is equal to, in place of this, write cos x. So here, observe the imaginary part. I into x minus x cube by 3 factorial plus x power 5 by 5 factorial, and in the next step, in the next term, what do we get? Minus x power 7 by 7 factorial and so on. So this will continue. So this is the expansion of sin x. What it is? Expansion of sin x. X minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial and so on. So right here, sin x. So this is said to be an Euler equation. What it is? An Euler equation. E power ix, which is equal to cos x plus I sin x, is called an Euler equation. I think I hope you have understood how I have written that. So here you would have to remember one more point. Replace x by pi radians. Replace x by pi radians. X equal to pi radians. If you write x equal to pi radians, this is going to be I into pi radians, which is equal to cos pi radians plus I sin pi radians. So here I pi, which is equal to cos pi radians, which is equal to minus 1. You know that. So sin pi radians is going to be 0. So 0 into I, which becomes 0. Now bring it to the left side. So e power I pi plus 1 equal to 0. Remember this. E power I pi is equal to how much? Minus 1. When you bring it to the left side, then it will become e power I plus 1 is equal to 0. Thank you.